Sure, here is the text from the provided images. Music and the emotions. Neuroscientist Jonah Lehrer considers the emotional power of music. Why does music make us feel? On the one hand, music is a purely abstract art form, devoid of language or explicit ideas. And yet, even though music says little, it still manages to touch us deeply. When listening to our favorite songs, our body betrays all the symptoms of emotional arousal. The pupils in our eyes dilate, our pulse and blood pressure rise, the electrical conductance of our skin is lowered, and the cerebellum, a brain region associated with bodily movement, becomes strangely active. Blood is even redirected to the muscles in our legs. In other words, sound stirs us at our biological roots. A recent paper in Nature Neuroscience by a research team in Montreal, Canada, marks an important step in revealing the precise underpinnings of the potent pleasurable stimulus that is music. Although the study involves plenty of fancy technology, including functional magnetic resonance imaging (fMRI) and ligand-based positron emission tomography (PET) scanning, the experiment itself was rather straightforward. After screening 217 individuals who responded to advertisements requesting people who experienced chills to instrumental music, the scientists narrowed down the subject pool to 10. They then asked the subjects to bring in their playlist of favorite songs. Virtually every genre was represented, from techno to tango, and played them the music while their brain activity was monitored. Because the scientists were combining methodologies, PET and fMRI, they were able to obtain an impressively exact and detailed portrait of music in the brain. The first thing they discovered is that music triggers the production of dopamine, a chemical with a key role in setting people's moods, by the neurons, nerve cells, in both the dorsal and ventral regions of the brain. As these two regions have long been linked with the experience of pleasure, this finding isn't particularly surprising. What is rather more significant is the finding that the dopamine neurons in the caudate, a region of the brain involved in learning stimulus-response associations and in anticipating food and other reward stimuli, were at their most active around 15 seconds before the participants' favorite moments in the music. The researchers call this the anticipatory phase, and argue that the purpose of this activity is to help us predict the arrival of our favorite part. The question, of course, is what all these dopamine neurons are up to. Why are they so active in the period preceding the acoustic climax? After all, we typically associate surges of dopamine with pleasure, with the fulfillment of a desire, not with the anticipation of it. This, the scientists argue, is the paradox of chills have yet to arrive, when the melodic pattern is still unresolved. One way to answer the question is to look at the music and not the neurons. While music can often seem, at least to the outsider, like a labyrinth of intricate patterns, it turns out that the most important part of every song or symphony is when the patterns break down, when the sound becomes unpredictable. If the music is too obvious, it is annoyingly boring, like an alarm clock. Numerous studies, after all, have demonstrated that dopamine neurons quickly adapt to predictable rewards. If we know what's going to happen next, then we don't get excited. This is why composers often introduce a key note in the beginning of a song, spend most of the rest of the piece in the studious avoidance of the pattern, and then finally repeat it only at the end. The longer we are denied the pattern we expect, the greater the emotional release when the pattern returns, safe and sound. To demonstrate this psychological principle, the musicologist Leonard Meyer, in his classic book, Emotion and Meaning in Music, 1956, analyzed the fifth movement of Beethoven's string quartet in C-sharp minor, Op. 131. Meyer wanted to show how music is defined by its flirtation with, but not submission to, our expectations of order. Meyer dissected 50 measures, bars of the masterpiece, showing how Beethoven begins with the clear statement of a rhythmic and harmonic pattern, and then, in an ingenious tonal dance, carefully holds off repeating it. What Beethoven does instead is suggest variations of the pattern. He wants to preserve an element of uncertainty in his music, making our brains beg for the one chord he refuses to give us. Beethoven saves that chord for the end. According to Meyer, it is the suspenseful tension of music arising out of our unfulfilled expectations that is the source of the music's feeling. While earlier theories of music focused on the way a sound can refer to the real world of images and experiences, its connotative meaning, Maya argued that the emotions we find in music come from the unfolding events of the music itself. This embodied meaning arises from the patterns the symphony invokes and then ignores. It is this uncertainty that triggers the surge of dopamine in the caudate as we struggle to figure out what will happen next. We can predict some of the notes, but we can't predict them all, and that is what keeps us listening, waiting expectantly for our reward, for the pattern to be completed.